You can get an eye on them.
Okay, so this is Connor speaking. My contribution so far has been the ADAS focused stuff. I'm trying to emulate the LIDAR sensors present on Starship robots, and these are going to be essential for things like automatic braking and obstacle detection. Once we have self-driving robots that are just other guys out in the world, these are going to be essential for actually piloting them and making sure they don't just go into the street when there's a car coming and stuff like that. Pretty important. Those blue lines you see, this is a sort of demonstration shape. There's going to be less of them, and they're going to be like on the sides of the bot where the sensors actually are. And if you drive towards a thing, right now it detects only people on the street as obstacles. So you'll see in the console down on the bottom left, it sees once there's a person in front, it hit an object, and that was the person directly in front of it. It's going to print a lot of times because it's like every physics frame plus how many things there are. Going forward, I'm going to add some more hooks so that the data can be read by other things like the bot itself and some UI elements. And yeah, that's what I've been doing.
That was fantastic.
That was good.
This took me quite a while because it's been a long time since I've done geometry, math, and this is 3D geometry, which I didn't do much of in high school. So I did some really epic sine, cosine, tangent type stuff, and it has a double nested for loop. S is the horizontal motion. That's how many iterations it will do. Like, think of it like a sprinkler, I guess. It's going and casting all those lines, and then it looks up by one, which is T. T is the vertical passes. It goes up one and then across, and basically it just shoots all the lasers out there and detects if it hits something. It only hits certain types of objects, so that way it's not detecting the ground every time the ground is below you, which ideally is most of the time. It only hits people and cars, and then like things like grass that the robots don't want to drive on normally. I know it's not a lot of code, but it did take me a significant amount of time to get the math right and working. So yeah, this is my magnum opus.
Okay, I'm Kevin. I guess my role for this group is I'm mostly focusing on UI overlay stuff, working in conjunction with Honor's Raycast. We want to have some sort of visualization for when the robot is going to hit a specific object on the UI. So what we're thinking is to get a polar graph and then have the robot in the middle of the graph. Then when a robot if robot is close to a specific object, one of the directions on the UI will light up, indicate to the player that they are close to the object. I got this title screen. That's the one thing that I finished. Yeah, just helping out the team wherever is needed is kind of my goal as well.
Nice.
Epic. This is what I did.
Hi, this is Riley speaking. My pretty much main role on the project is to do all the map building, the 3D modeling, and the texturing of our objects. We decided to go with trying to make a realistic version of the Oregon State campus and reasonably to scale. So I started around Dixon because they have a lot of these Starship robots make deliveries from there, starting there. So all of this modeling was done in Blender, and then the textures were taken from pictures either that I've taken myself around campus or my teammates, or pictures that I have taken from like Google Earth or online. So another thing I've done is the actual model itself of the robots, and then made sure that the origins for the wheels and things are set up correctly so that they actually spin around. Yeah, I think the plan is to model as much as campus as possible, specifically starting with places that the robots deliver to, like dorm halls or the MU and things. So as you can see, this is the progress from winter term. We'll probably start with roads and sidewalks, so Ethan and my other teammates can have more real estate to work with, and then from there we'll block out the buildings and get the details so it looks better than it does at the moment.
Hi, this is Ethan speaking. Here is the map that Riley showed, but with some of my elements now added to it. We have a vehicle route system that we built, a pedestrian route system, and then a delivery system. We have the three of those right here. We also have a beacon that we use to show what location the player's supposed to drive to next. We'll get animations in for these characters, but for now they're kind of just T-posing around. They walk in the path that we have set before them. They're affected by gravity, that they stay on the floor correctly. And then the same thing's happening here with the vehicles. Our beacon has spawned over at this red circle. The red circles are start locations for deliveries, and the green ones are delivery locations where you're supposed to bring the food. Once you reach one of those locations, it will tell you to go to one of the green ones, and then after that, it will give you a new set of 2 locations to go to and from. Yo, what was that?
That's a little bit of a problem.
Why did you send that during Ethan's
It's okay. We can cut it.
It's so funny.
I'll continue on with my thing, but I'll just do it here now for the rest of it.
Well, it sounds like you don't have. Like,
Here I go.
Oh, sorry,
I'm gonna
Ethan.
go. I'm gonna do it.
Go ahead.
Okay, I'm gonna do it right now. Here's the code that I've completed. These ones are my files. Here's the player controller. It's basically just referencing a bunch of objects in the scene, getting player input, making them move, making them look forward the whole time. And then we have 3 different editors, and then some handlers. Pedestrian editor and vehicle editor are essentially exactly the same. One's just for vehicles, one's just for pedestrians. Here you can draw these wire spheres, and they're connected with lines that you can visually see the routes. This one I set to orange in the editor, this one I set to blue, and those are really the only differences. But then here, pedestrian, the walk-on path only references the pedestrian path editor. This one only references the vehicle path editor, and it just, you get a speed, and then you give it a starting point. The default is 0, and then it will move towards that starting point and then turn towards the next one and continue on its path. Here's the delivery editor. Here you're just drawing wire spheres at a collection of start locations and a collection of end locations that are both inside of these 2 game objects called starts and ends, which can be found right here. We got the collection of starts, the collection of end, and then here is how all of those objects are handled. It will originally say that start and end is reached, just so it can tell you to get a new delivery. When you get a new delivery, it will create a waypoint. Well, first we'll get a delivery, which sets your start and end location. And then we'll create a waypoint at your start location. Once you reach that location, it will say that start is reached, go to a new one. And then once start has been reached and you've reached the end point, then this goal complete, which will loop you back to here and give you a new location. Essentially it for the code, and then just had to put it all together in the scene here so it looks right. Yeah, okay, I'm done. I'm saying weird stuff, so we cut it here.
such a yummy snack.